Hi, yeah. Hi, I'm Veer Satya. In the previous video, right, we have discussed about the project plan. I will give the link in the description of this video. What is the require? In that video, I've discussed about the requirement and the project plan. So in the current video, I'll be discussing about the software requirement specification. So for the same project, IRD AWS IOT. So also we'll just go through this. So in this, basically in the software requirements, right, you will have the overview of the functional requirements and the non-functional requirements before you start the project. Basically, you'll have the firmware, right, which is developed using the Quectel Python framework, right? And the scope will be identified. So the scope, so what are the features you are implementing? Like for example, here you are implementing a MQTT functionalities, connect, subscribe, publish, and disconnect. Then you'll have the TLS encryption, designing and implementing of low power operation mode. Then you'll have the documentation aspects. So you'll in the next section you will have the acronyms and definitions and abbreviations. Then the references. So what are the other documents, right, which I've referred for coming up with the uh, requirement specification. The product, right? So the description of the product will start here, and what are the functions, right? And like for example, we'll just go through. So the subscribe protocol, right? Subscribe function, specific MQTT topics, right, to receive messages. Basically, a MQTT, right, is publish and subscribe protocol. So in that, one of them is subscribe, and then you will have publish. So you will see in this, right, you will be implementing sending data to AWS I2 Core by publishing messages to designated topics. So there will be some topics, right, with the users will subscribe here. Then the disconnect feature, safely disconnection from IoT core. Then you will have TLS encryption. So you need to encrypt all the data, right, while you are sending between the client and the AWS server. Then you will have the low power mode. Low power mode, basically, right, you'll just switch off some of the functionalities, right? These are the user classes who are working on this project, right, and who will be using that project and all. Then you'll have the operating environment. So operation environment, so how the firmware will run, right? So the normally the firmware will run on Quectel hardware only, which will support Quectel Python environment. So and the conditions of the operating environment, right, will be depicted in here. So about the temperatures and design and implementation constraints, you can give the constraints here, like limited processing power and significance of the memory of the IoT device. So normally IoT device are memory constrained, so you need to give the limitations here. So to extend the battery life, right, you need for consumption. So you need to comply with the bigger AWS IoT core security requirements. Basically, as you are communicating with the AWS IoT core, right, from the device, so whatever data you are sending, you need to send with the security aspects pertaining to AWS IoT cores. So some of the assumptions, right, you can mention the assumptions and dependencies. Like for example, you need to have a stable network, right, for when you want to communicate with the MQTT. Then the Quectel Python, right, should support all the necessary hybrids and APIs, because whatever framework or the SDK you have, right? So it will be on top of a particular hardware. So the SDK will call the hardware specific functionalities in the device. So the testing of the particular SDKs, right? Whatever APIs we are using, right, that should work properly well. So yeah, that is that. And also the AWS IoT core credentials. That's more pertaining to certificates and keys, private keys here. So then we'll start with the functional requirements. So first one is the MQTT connection management. So however, the firmware must establish a secure connection to AWS IoT core using a MQTT protocol. So here, right, yeah, the communication, right, between your device and core is MQTT protocol. So you need to have the MQTT client and also, right, you need to have the input and output mechanism. So inputs, what are the inputs you are using there? It is AWS IoT core endpoint, okay, device certificate and private keys. So this will be the input for the MQTT client here, and the connection confirmation or error messages. Output, right, when you get a confirmation of the connection, right, will be either success or failure. So what kind of processing you are doing here? So initialize the MQTT client, then perform the TLS and establish a connection. So these are the different three phases for pertaining to this MQTT connection. So this is a particular requirement here. Then you have MQTT subscribe. So here you need topic names, right, as the input, and output will be messages received from subscription topics. Processing, so listen for incoming messages on the subscribed topics and trigger appropriate actions. So once you are subscribed to a particular topic, right, so all the messages, whatever incoming messages you have, right, so based on the topic, right, whatever so there will be event handlers. So you need to do some action once you get some topic subscribed. Then MQTT publish. So there is a topic, right? Suppose temperature is a topic here. So you need to publish the temperature of the sensor. So inputs will be topic name and message, and you have the outputs will be confirmation of the message delivery or the message, and your package in the data applied and published to the topic. Then you have MQTT disconnect. Firmware must safely disconnect from IoT core. So disconnect command, disconnect confirmation. So this is more like a discussion. Then you have the TLS encryption. So all TL MQTT communication must be encrypted using TLS. So this more pertaining to how we are getting the all the messages, right, on par with the TLS mechanism. So inputs will be data to be transmitted in encryption keys. Then output will be encrypted data stream. Apply processing, apply encryption during transmission. So whatever data you send to and fro, right, whether you to the client or from the client, you have to encrypt the data and send it out and receive also in the same fashion. Then you have the low power mode. So firmware must implement a low power mode to conserve energy during period of impact. So device activity less. So you'll check the device is on or off right here. So if it is off, it will go to low power mode. So there when there is no activity basically. So here, right, processing will be it will be monitored every time, so to enter into the sleep mode. And so there are some non-functional requirement as well. So non-functional would be, so what is the time frame, right, connect to, right? So here you are giving it as 3 seconds. Um, the firmware should consume minimum power during low power mode, extended battery life at least 6 months under Tiffin. So because to consume less power, right? So you need to have this low power mode, and the battery what you have, right? So IoT device, so battery operated device, right? It should be for typically 6 months. So if you don't have low power mode, then the battery consumption will be more, and also the life will reduce. The security, all data transmitted between IIT core and AWS IoT core must be encrypted. So that we have already discussed. Firmware must, so this is already reliability, the second aspect. And so usability is the error message. How do you use the particular different components, right? It will be given in the user manual, and the APIs, right, whatever you are providing. So you'd go provide some developer guide, so that, right, any third party developers, right, can enhance this product. And maintainability and version controls. So you'll have other requirement, like you need to have the firmware design documents, so that we'll discuss later. Okay, then the developer guide and the testing aspects and delivery and deployment methodology and the deployment mechanism. Yeah, that's it in this video. Thank you.